campus. My name's Becky Ford. I'm wearing two hats tonight and one T-shirt. The T-shirt tells you I'm part of the Orkney International Science Festival. So welcome on behalf of the festival. And for those of you who haven't signed up for more events, there's still one more day to go. So have a look at the programme and get along to tomorrow's events. I'm also wearing an OREF hat because I'm one of the board of directors for Orkney Renewable Energy Forum. And tonight's event is a collaboration between the Science Festival and OREF. I'm delighted to welcome our speaker, Mike Tyndall from Aqua. You may have heard on the news this week announcements about an electric ferry for Orkney. Mike is not the electric ferry person.
Sorry to disappoint.
I'm going to get that out there because I knew it was going to be the first question. Mike is actually going to be talking to us about his project, which is the title for this talk was A Hydrogen Ship for the Aberdeen Run. So Mike will tell us about the plans to put an autonomous cargo vehicle running on hydrogen between Aberdeen and Orkney and Shetland. Mike Tinmouth is Chief Operating Officer at Acua Ocean, which he co-founded in 2020 with his brother Neil. They originally heralded from South Shields and several generations of River Tyne pilots, which was the start of their shared love and respect for the ocean. Mike has spent the last decade working in and advising high-growth tech startups with a specific focus on GovTech. He holds a Bachelor of Laws degree with a major in maritime law and an MSc in Risk and Security Management. In addition to his role at Aqua, Mike has spent the last 4 years as an innovation mentor and business coach to the Royal Navy, US Navy, and the UK Ministry of Defence. Thank you, Mike, for joining us this evening. We look forward to your talk.
Thank you so much, Becky, and the entire team from the Orkney International Science Festival putting this on. I'm thrilled and delighted to be here this evening and share a little bit more about our journey, some of the challenges, the pain points that we're experiencing, but also the massive opportunity. And an absolute delight to spend the last sort of 48 hours sort of on these amazing islands. It has been truly spectacular, and the weather has certainly been sort of very welcoming as well. So, well, as mentioned, I'm going to leave plenty of time at the end for questions. If there are any sort of burning questions as we go along, feel free to stick a hand up, but I think we'll save the majority of questions for the end. I'll be very happy to go back through any slides. So I inserted the word autonomous in there because hydrogen just wasn't complex enough. We also had to make a drone ship. So that really sort of sets a little bit of the theme for this evening. All right, and I think. Fantastic. So there's going to be a lot of slides. Some of them will be very maritime-y. I think this speech is, I wanted to try and make it as sort of engaging as possible. So I'm going to touch a little bit on alternative fuels, a bit about naval architecture, about the broader challenges that autonomy faces, the opportunities it creates at the same time. I realize some of these subjects are very contentious as well. So feel free to also challenge me during the question and answer session. So I certainly don't want either my business, our product, or our solution to just exist in an echo chamber. We need feedback, and part of that is attending events like this and getting sort of real life sort of perspectives. Ultimately, any vessel that we're looking to build and sort of produce, manufacture as a solution is all about being dual use. And one of the biggest challenges and the reasons we formed this company was looking at the real opportunities in the broader ocean space. And so we're going to talk a little bit about cargo and logistics runs, but also around defense and security of critical national offshore infrastructure. We're going to talk about marine protected areas and the likes as well. But I think this really, for me, summed up part of the challenge with the ocean. It's an extreme environment, which sort of adds to the cost, to the complexity, to the scalability of the types of solutions that need to be developed. But it's also critical to life on this planet. It's the world's largest interconnected biosphere. $3 trillion blue economy. About 2 billion people rely on the ocean as their primary source of nutrition. And when it came to the defense sector, this was one of the most sort of interesting discussions that I recently had with the Ministry of Defence, which is around the scale of the UK's EEZ. So currently we only have a single frigate in the Royal Navy patrolling 4.5 million square kilometers. There are lots of frigates, 10 to 13 in total, but actually assigned to overall patrol duties, just a single vessel. That would be the equivalent of having one police car to patrol the whole of the mainland of the United Kingdom. So the ocean's a big space and is very expensive to operate and build solutions. The new Type 26 for the Royal Navy, about 1.2 billion by the time it's fully sort of kitted up. So it's a costly exercise. What we're also seeing is the increasing challenge, when I said with climate change, the massive growth in offshore infrastructure, be that subsea cables, pipelines, growth in offshore wind, but also a whole risk in terms of illegal activity as well. That could be interference by foreign nation states. It could be illegal fishing. It could be dumping of waste, pollution, discharge. So the oceans are under threat, and we need new and scalable solutions to really address these challenges. We also need to be proactive in the way in which we do that. We need to reduce the cost, because otherwise the cost to the consumer is just too high. I think everyone will have recently seen the offshore wind auction, where not a single bid went in, because the cost is simply too great to operate at sea. It's about a factor of 3 more expensive than it is on land. What we're also seeing is increased amounts of congestion. So around about 12 to 14% of all ISO container, 20-foot ISO container logistic movements on shore could be replaced by nearshore shipping. So the movement of containers from port to port via low-cost solutions rather than by road. And finally, there's the challenge of how can we crew and sort of resource a marine sector which the UK is just falling out of love with at the moment. So Southampton University, who are a partner of ours and we've been working with for the last 3 years, they've got one of the best known marine naval architecture centers in the world, Southampton University Marine and Maritime Institute. But they still receive 40 times more applications for aeronautical degrees than they do for marine sciences. So what we're looking at is this combination of new solutions, new technologies to move away from the dull, dangerous, dirty jobs of the past and the distant jobs. People don't necessarily want to spend months at a time at sea. They're looking for new solutions, new opportunities, higher paying jobs and roles that are less dangerous. And so my talk tonight and sort of some of the areas I'll sort of dive a little bit more detail into are really exploring what technology can do as a solution and how that's relevant to sort of big challenges of state, to local communities and the likes as well. And one of the very first challenges we sort of see in this space is that people think about the marine sector in the way in which they've always thought about it. These are 2 of the leading autonomous drones in this sector, but they look like a kite surfer and a sort of little fast rib type sort of style boat with a big gun on the front of it as well. Nobody's thought about how we can use new technology to think outside of the box. And that's where we were trying to sort of build up a solution. We were trying to sort of essentially reverse engineer what's the problem, but what is the opportunity? How can we use technology, autonomy, novel fuels, hydrogen and the likes to really engineer a new solution to these problems? But the challenge that everybody has in this space is that as soon as you talk about more capabilities, as soon as you start talking about we need more power, we need more endurance, we need bigger sensors, we need to be able to deploy bigger ROVs for subsea inspections, the solution has always been to build a bigger boat. And this has been one of the real sort of challenges is we saw a competitor, in fact, I'll go back a slide. So Sail Drone started off with a 7-meter vessel. This is a Brit from Portsmouth who moved to Silicon Valley in the US, founded Sail Drone 2017, started off with a 7-meter vessel with a vision, 0 emission, wave, wind, solar power. The problem, it had no speed, had no power for comms, no power to actually collect anything of any use. So they went bigger, and then they went bigger again. And they actually ended up with a 24-meter with a diesel engine. still had the sail, but there was nothing on it. The sail basically topped up everything else it did. So their entire vision of this zero emission future got unraveled by the fact commercial requirements are for you to have something at sea that is managing, is able to deliver a real sort of outcome. And then this really just couldn't. The other challenges we start to face in space is just perception. So as I started off and said, look, when it comes to buzzword bingo, we're scoring pretty highly. We went with autonomy, and everybody thinks that these are drones and robots that are going to take over the world. And the second one is, and this is my favorite, particularly with American investors. Every time I go, I'm building a hydrogen-powered boat, they go Hindenburg. I mean, literally, I can almost not finish a sentence without somebody going, but wasn't there an airship that once blew up? What they forget about is the fact that actually, hydrogen has been successfully used in commercial applications for decades. It is intrinsically, as we'll see on a couple of slides, actually a lot safer than some of the other sort of gaseous solutions that we use in other sort of day-to-day parts of sort of our everyday lives. So actually, a lot of this is misconception, but this is the public perception that we need to overcome. And this also applies to other fuels. We are a hydrogen-powered vessel, but we're also looking at ammonia, methanol, biofuels, and the like. Another challenge we face, and this goes back to that sort of the dull, dangerous, dirty jobs of the past, is if we're going to be developing new futuristic jobs, high-paying technology jobs, we've got a real challenge because the ocean is an unforgiving master or mistress. What we're looking at here is the real challenge of, do we train mariners who've got experience at sea to be computer gamers, or do we take the next generation and train them to be mariners? Very, very difficult sort of balance to strike here, because if you've not been to sea, you certainly are not going to understand weather conditions, local conditions, which can basically change at the drop of a hat. Other challenges we are facing and seeing in this market is actually just hydrogen itself. Orkney is in the process of having a bit of a discussion beforehand around hydrogen production, but actually almost 100% of the UK's hydrogen gets shipped in from Amsterdam. So there are 3 European centres for the production of hydrogen: France, Amsterdam. We bring it all into the UK. The massive challenge we have is that there is this drive towards green hydrogen, zero emission, coming from sustainable energy sources. But UK legislation says that any hydrogen transported logistically in the UK can't be in a zero emission vehicle. It has to go on the back of a diesel vehicle. So automatically, any green hydrogen in the UK is not green by the time it reaches its destination, because the road haulage legislation hasn't caught up with the zero emissions requirements. Now, hopefully that's going to change very soon. But that's the sort of challenge we face. We face challenges with the supply chain, talent, manufacturing. When we looked at quotes and estimates for producing and manufacturing some of the key components for this vessel, 50% cheaper anywhere else in the world, because all of our skills have been outsourced. We're trying to bring that back by developing a local supply chain where possible. There's also huge issues beyond just zero emission fuels. And I think we've got here in this, particularly in the UK, we've got a little bit of a sort of a crisis that is going to be developing. I think this is bubbling up beneath the surface, which is actually why we're just looking at the emissions from the fuel and not the full life cycle emissions. And this really plays into a topic which I believe is also quite topical among members, which is one of my big areas of concern, which is lithium-ion batteries. So many people would have seen a couple of weeks back, I think it was a car ship coming over from Amsterdam, where potentially a couple of vehicles caught fire from the lithium-ion batteries. As a result, the vessel, substantial damage. I think it was actually loss of life as well, but it certainly was a rescue at sea situation. So lithium-ion batteries are particularly nasty. And when it comes to zero emission, what we're talking about is solutions which are hydrogen through a hydrogen, in our instance, liquid hydrogen, I'll show you in a second, liquid hydrogen to a PEM fuel cell, but we're charging a lithium-ion battery. And so whilst we are zero emission from a fuel perspective, we're still having to count and need to do more around the lithium-ion batteries, the risks that they pose both in terms of the mining of the lithium ion, but also the decommissioning at the end. And probably the biggest sort of challenge we face as an industry is the lack of success stories. The UK has really struggled, and Europe broadly as well, has really struggled to show those growth companies. When you look at those billion-dollar, multi-billion-dollar companies, those unicorns, we're not producing enough of them. And that's restricting private investment into these sectors. But it's not all doom and gloom. There are massive opportunities underway. And we're trying to build a company, I don't have aspirations of being Elon Musk. I certainly don't speak with Elon Musk's confidence, but I certainly believe that there are massive opportunities, and the marine sector is incredibly exciting. We do have talent in so many areas. We may have talent shortages, but we've got a great history as a seagoing nation and massive opportunities to grow in this space. But we need the right type of support, the right type of engagement, the right type of ambition to show that this technology actually works and can scale. And this will tie in a little bit to the project I'll talk about at the end. So the challenge and capabilities requirements that we are sort of trying to address, and this is where I start going into a little bit more about the technology behind our vessel before I go into the project. So ultimately, whether we're looking at marine protected areas, whether we're looking at sort of Ministry of Defence work, whether we're looking at cargo, logistics, servicing of offshore sort of infrastructure from subsea asset integrity inspections and the likes, you need three things: persistence, endurance, time at sea. The challenge you've got with crewed vessels is they want to go home. They want to see family. They don't want to live at sea. What the autonomy enables you to do is to spend longer at sea, because you can run shift patterns from a remote operating centre. So that endurance and the reliability that you get with hydrogen systems and the likes means that we're able to deploy a vessel that could be out at sea for 40, 60, 80 days. That very first sail drone vessel, that one, the little 7-meter, 360 days it could stay at sea. It didn't do anything, but it stayed at sea for a very long time. So satellite technology is great for a lot of the use cases. Clearly, if you're moving cargo, satellites isn't the way to do it. Great for data, or actually not so much for data, because about 95% of UK data is transferred via subsea cables. But when it comes to things like ocean monitoring and like, satellites are really useful. The next one is the operational sea state, and this is the one that catches everybody out. The number of my competitors whose beautiful marketing brochures show vessels on glassy lake. I mean, I think that's probably somewhere in Switzerland, and nowhere near actually an open ocean. I mean, I think even that looks like a sort of a quiet day, maybe in the Caribbean or in the Med. Well, when it comes to actually operational environments, the types of places you want to deploy these vessels, if you're doing sort of ASW, anti-submarine warfare detection, if you're out sort of supporting North Sea oil rigs, you don't want to be, you're not going to be operating in this. You need to be looking at 2, 3, 4, 5 meter sea states and above. Now, one of the big sort of challenges for anybody operating a crewed vessel is that at about 2 meters, you're down tools from a safety perspective. Autonomy enables us to start rethinking that. We can start deploying systems in 4-meter sea states because the safety risk from a human risk to life perspective is substantially lower. And scalability, cost, it's just very expensive. If you're building these big boats that need a toilet, a galley, bunks, corridors, all of that sort of infrastructure that you need for people on board, when you go autonomous, you can rethink your design. And so that's where our vessel came in. And I'll talk you through a little bit more about where we are from a build and development perspective. But we've gone for an entirely new and novel shape. In fact, some people go, isn't that a catamaran? It's actually called a swath vessel. So it's been around as a design from probably about the 1960s, but swath stands for small waterplane quin hull. And essentially what we've done is we've redesigned, re-engineered based upon optimum capabilities for this vessel. So what we've got is 2 cryogenic liquid hydrogen tanks stored beneath the waterline. One of the real benefits, and I talked about actually how you build capabilities into things like your source of fuel, is that so each of these tanks contains 3,000 litres of hydrogen. If that was diesel, that would be incredibly heavy. Because of the nature, and as you burn diesel, so the vessel will become lighter. So your stability, your balance would change on the vessel. Because this is hydrogen, the total weight of the 6,000 litres of cryogenic liquid hydrogen on board is 420 kgs. So as we burn through hydrogen, we're not actually changing in any meaningful way, changing the displacement of the vessel. This makes this a more stable platform to start with. It gives us a huge range of capabilities as well in terms of size, and just a little bit in terms of dimensions and things. So this is a 25-ton, so this isn't a bathtub toy, but it's also not massive. You know, we're not replacing an aircraft carrier, although those are drones for a future iteration. What we're looking at here is a 13-meter by 9-meter wide platform, specifically to deploy cargo and payloads. So what we've got inside of the fore and aft weather deck here is compartments which can carry up to 3.5, 4 tons of payload, which will be making the run from Aberdeen to Orkney on next year. But it enables a whole load of other capabilities in terms of communication, sensors deployed beneath the waterline in the nose cones, environmental sensors. So if the vessel's doing its crossing from Orkney to Aberdeen, this vessel will also be collecting eDNA, marine biodiversity data, ocean alkalinity data, all fed back to scientists around the world. That's what we're talking about when it comes to dual-use platforms, multi-role platforms. So I touched on a little bit of this already. Stability from vessel design, long endurance. The prototype we're aiming for 40 days, but it can certainly, the intention is to get between 60 and 80 days of use for the MOD. Enhanced sort of data comms, large modular design. So this entire vessel can be disassembled and put in 40-foot ISO containers to be shipped anywhere in the world, rapidly deployable, and lower cost. So this vessel being used for anti-submarine warfare. So public knowledge, we've got a Ministry of Defence contract that's out on the internet. This vessel deployed will be about £2 million compared to a 1.2 billion pound fleet doing ASW. So where are we in the design phase? Now, I do realize this looks somewhat like a rocket, a little bit like a torpedo. It certainly sits beneath the waterline. So this is the cryogenic hydrogen tank, which has been built, manufactured, certified by Lloyd's Register, and deployed from a factory acceptance test perspective. So I said 9 meters long, 2.5 tons, cryogenic, so it's firmly lined, insulated, pressurized cylinder as well, and takes 3,000 liters of cryogenic liquid hydrogen. We have built out the internal systems, which I can show there's a huge amount more engineering than it looks like. This probably looks a little bit like somebody's electric board at home. But this is running a whole range of sensors, propulsion systems, comm systems, and the likes as well. We've run the hydrogen through the entire system, and we're in a really, really good place in terms of integration and deployment. So we've started the build of the vessel sort of very recently, having just completed tow tank testing with the University of Southampton, who I think is the next. Oh no, one more slide and then the next slide. Before I come to a little bit more about the whole form and shape, and then sort of go on to the project. What we also conducted is a whole range of blast studies, and I talked about the intrinsic safety because people go hydrogen, I go hydrogen, you go Hindenburg. What we really started to look at was around some of the safety considerations, the blast zones. Somewhat dramatically, they do call it the kill zone, which is not a term that I tend to like to use. Look, this is far sort of safer when it comes to in terms of safety processes, procedures, bunkering procedures and the likes. We worked extensively with the Maritime Coast Guard Agency, Lloyd's Register, a couple of specialist providers here as well. This is safer than a lot of the marine diesels that you use. But what we were able to really demonstrate is, in fact, liquid hydrogen is safer than even gaseous hydrogen. And they're talking about putting gaseous hydrogen into people's homes. So what you've got here is sort of various radiuses of potential explosion, blast, pressure waves, and the likes. One of the intrinsically sort of safer things about the design is that we're also storing it beneath the waterline. So hydrogen, the most abundant element in the world, means that essentially anything is dispersed. Now, you don't want to be right next to it if there was a tank rupture or anything else. You don't want to be in the immediate 1 meter proximity, but it will disperse into the water. It will cause no environmental harm. Significant testing to demonstrate that. But it also means the risk of blast and explosion are completely minimized. And so hopefully And we'll play. There we go. I've just included two videos here. This one was from earlier this year at the University of Southampton. They're totally brilliant. It looks like a big swimming pool. And apparently the GB outdoor swimming team trained in it, so they put the waves up. Essentially, what we're starting to simulate here is waves that are 2-meter wave height. This is the operational wave height at which the likes of Chevron will down tools. They will not deploy an ROV for some sea asset integrity inspections. But what we're aiming to prove here is that this platform, autonomously, you haven't got people at risk, but actually also provides a level of stability which you wouldn't get with a traditional monohull. With the swath vessel design, and as I said, this is a 25-ton vessel that we're building, performs with a 15 times stability calculus than a monohull. So you would have to basically be deploying a 350-ton vessel to perform with the same stability that we'll be getting out of the HUSV that we've developed. The next example, so you're not my vessel, but what you can see in the foreground here, so you've got a swath vessel. So it's very actually, swath vessels were originally used for crew transfer vessels. So you can see the performance and the stability of the swath vessel in the foreground. Sorry if I pushed the wrong button there. Let me try that once more. If it works the second time around. It's also a very short clip. You can see the performance of the swath vessel versus a traditional sort of pilot vessel, where I think that may even be a Coast Guard cutter, maybe. And you can see the slamming effect that you get with a monohull vessel versus the stability you get with the swath, the way it sort of planes through the water. So I talked a little bit about sort of mariners and gamers and mariners. One of the great things that we're looking to do is to move. It's one of the most contentious parts of, are you not taking away jobs from sea? Well, firstly, there is a decreasing workforce in the offshore environment. I don't know if anyone saw, but the Irish Navy recently had to mothball 2 of their vessels. They simply couldn't recruit enough people to crew them. The Royal Navy, massively, massively understaffed at the moment as well. What we're looking to do is essentially bring jobs with mariners to shore. So Rob, with the harbour master, now, well, obviously he was harbour master, he was on shore, but he's now working in our remote operating centre, which means that what we're able to deploy is a whole range of technology, not just command and control and operations of vessels, but actually starting to, as I said, starting to collect scientific data as well at the same time. So if we are doing a cargo run, and we're looking at cargo runs, and I'll talk in a second about the project, cargo runs out to Orkney, but also out to the North Sea sort of rigs. What we're able to do is collect that rich amount of data as we go along, with that dual use, multi-domain operations that come with it. Quickly, just on our timelines before I move on to the project. So, as I said, we factory acceptance tested the vessel, internal systems, the hydrogen systems, the tanks and the likes. We factory acceptance tested that earlier this year. We're moving towards sea trials, which are going to be undertaken down in Plymouth, probably April next year, May as a fallback, and then we start our visit out to the amazing islands, or isles rather, Orkney and Shetland. Spelling mistake, sorry, typo on the move. My hope is to be here in August, September next year, which is a very ambitious timeline. Certainly by the end of October, I want to have been completing the demonstrations. I'd preferably with a prototype, prefer not to be visiting in January, February time. It might be a little bit blustery on the quay side, but the intention is to get the vessel over to the islands for the first demonstration run. We're going to be taking, as I said, a sort of a 3.5-4 ton payload with us as we come. We're going to do multiple crossings back and forth, and then we're moving into commercialization with trials for the Ministry of Defence. So the last little section of the talk is a bit around about high-fived. And you heard a little bit earlier about the electric ferry, the Artemis ferry, which is being funded through the ZEVI project. So the UK government, through the Clean Maritime Demonstration Competitions, the Department for Transport funding a £206 million pot of money that runs up until March 2025. So it's in this sort of Treasury financial year, is being deployed around clean maritime. Now, just to put into context, Lloyd's Register just did a piece of research with Marine Capital earlier this year. They've estimated that to decarbonize the UK maritime sector will cost 70 billion base case. That's before you do anything particularly cool or exciting. The total pot of funding for UK maritime decarbonisation is 206 million. So it is very much a small drop in the ocean at the moment. But what we're trying to achieve here is projects that can demonstrate new technologies and success. And as I said, that big challenge is you don't unlock private investors don't take risks with their own money. What they want to see is they want to see the success stories. They want to see where are they going to make the 100 billion pound profit from. And they want this de-risked before they make the big investments, which will unlock decarbonisation. So our funding for high-fived, which slightly cheesily stands for Hydrogen Innovation, Future Infrastructure and Development, Evaluation and Demonstration, is the project that we're going to be deploying here next year. What we're working with across the sort of the user's sort of journey and platform is, for us at Acua Ocean, there's actually 8 partners on this project. So the Port of Aberdeen are a key partner. Unitrove are going to be developing a liquid hydrogen bunkering facility. So on the key side, the deployment. And then who we're working with here are DPD, DHL and Streamline Group. So Streamline are one of the major sort of couriers doing most of the logistics back and forth from Aberdeen to the islands. What we're trying to demonstrate is we're not doing it. We're a 25-ton vessel with a 4-ton payload at the prototype. We're not in the process of replacing a cargo ship with thousands of tons of cargo on board. That's not us. What we are looking at is how we can move towards a 20-foot ISO container, 40-foot ISO container that's able to carry 20-ton, 35-ton payloads and could be doing just-in-time logistics delivery, could be doing inter-island deliveries, could be doing near-shore shipping between ports, be going out. One of the biggest costs in the North Sea right now is that they always have to have those large SOSV vessels on standby. So if part, component, something critical goes down, you've got to have a vessel onshore ready to go to send parts out and components out. Those vessels typically operate at a cost around about $50,000 per day. When you're talking about an autonomous vessel, you're talking about $5,000 a day. So the ability to actually replace these kind of logistic supply chain routes with more regular, smaller services becomes a really interesting and very, very scalable model. The example that DPD gave us, and one of their biggest challenges is, they're all about green. Their customers, their consumers are demanding green solutions. Their shareholders are demanding green solutions. They currently pick up a package in Cornwall and take it all the way to the Port of Aberdeen, zero emission, battery EV vehicles, beautiful and green, gets on a big dirty diesel ship, comes across the islands, gets picked up in a beautiful EV vehicle. And what they want to do is be able to demonstrate that you can have an end-to-end supply chain. So what we're actually looking at with them is potentially, the plan is, without giving too much away, is we're going to be looking at the spaceports sort of down in Cornwall, one up in Shetland, being able to move logistics, parts, components, dry goods in between the two in September, October next year. The interesting thing from our technology partners' perspective is the ability to start building infrastructure at scale. And one of the real challenges the UK has, I don't know if it's on a future slide, but the UK has got about 1,700 marinas, small ports and harbours. There's about 246 ports and harbours, 1,500 marinas. Now, to completely decarbonise those is going to be an absolute logistical nightmare. I was sat on a working group with the Port of Dover talking around the decarbonisation of the Dover-Calais ferry through electrification. Very short run, 14, 15-mile run. Infrastructure costs from a port key side, manageable. The national grid would collapse. There simply isn't enough infrastructure to completely decarbonise. And so one of the real big challenges we face is, and sort of topics of conversation is, what is the solution? Is it electrification? Is it hydrogen? Is it ammonia? Is it methanol? I think the answer in the marine sector is it's more likely to be all of them. Different use cases, different solutions for different horses for different horses, to use an old pun. But what are we trying to sort of gain out of this run? What are we trying to look to deliver? Part of this is very much around, it's small, it's scalable, relatively low cost. And I think this is one of the areas where we've had degree of pushback. This project is funded by the UK taxpayer. It's £5.4 million project. There's no hiding from that. That is a relatively large sum of money when you consider the facilities that could be built with that type of money. But what you also need is you need that ambition in terms of new technology to de-risk solutions. So we're seeing the building of smaller autonomous platforms as being part of the de-risking. There's nobody on board. So from a safety perspective, it's a great way to prove novel new fuels without the risk to human life on the waterfront. It's also small enough as well. If we were retrofitting a ferry, 2 million ain't going to get you very far at all. You're probably talking 10, 15 million to fully refit one of the propulsion systems. So we're able to do it at a smaller scale at the same time. We're also then sort of looking at sort of wider logistics and supply chain, because that really is a massive challenge. Do we have the skills? Do we have those young, bright engineers coming through? The answer is in places like Orkney, yes. Actually, in a lot of the rest of the UK, we're falling behind and falling a long, long way behind as well. And as I said, this really talks around the scalability of these solutions. From our side, what we are looking to do, as a business sort of more broadly, is the ability to build lower cost, smaller platforms and deploy more of them. If you're replacing a £1 billion frigate with a £2 million vessel, you're able to deploy significantly more of them. Distributed maritime operations. One frigate chasing a submarine, a bit of a needle in a haystack, deploying 50, 60, 100 vessels to do the same job. If you're doing a site survey for a wind farm, deploying one vessel, mowing the lawn, going up and down, versus deploying 3 or 4 vessels to do the same area in a fraction of the time, reduces cost, reduces risk. Doing surveys more regularly reduces, increases things like predictive maintenance, which becomes really, really critical. A single point of failure on a data cable can cost about 20 million to rectify. So if you're able to do those regular surveys, collect that data, it reduces the cost and the risk down the line. So as I mentioned, early stage TRL, for those of you familiar with technology readiness levels, we're going to be moving the vessel from TRL 5 up to TRL 8. TRL 8 is kind of the point of commercialization. So we've got about 20 or so agencies, commercial companies involved in the project as well. I'm very aware, as you may also be aware, there's the Tati project that's doing aerial drones with 120, I think it's got 120, maybe up to 500 kilo package. What we're ultimately talking about is moving beyond 500 kgs, 4 tons, up to 20, 40 tons in future. And we're going to be here for about 4 weeks next year. So I've already said we'd love to participate in local events, activities, bring people in to look at the remote operating centre, to see the vessel when it's in port and harbour, work with schools and local communities as well. This isn't just a PR exercise. I genuinely am passionate about this industry. And as I said, huge opportunities sort of across the world. We sort of see this, as kind of a bit of a democratization of ocean management. Small island developing states, if you're somewhere like the Maldives, the Bahamas, the Seychelles, islands in Thailand, access to large vessels is really, really expensive. But actually, if you're moving to smaller autonomous systems, you can do a lot more with less. And this is where we're starting to see some of the real growth opportunities. We're seeing in small island states, we talked about sort of the logistics run and taking this payload package. But actually, if you're looking at places like Sweden, which is most islands in the world, or Indonesia, other sort of Caribbean islands, the ability to deploy those logistics, conversations we've actually been having with the port authorities in Los Angeles, is about using these type of logistics payloads in the event of an emergency. So if there was a massive fire on the California coast, or there was an earthquake, you actually needed to provide more logistics quicker into an area, could you deploy autonomous systems? Could the Royal Marines be using these to deploy equipment onto beaches quicker than sending vessels or heavy lift sort of helicopters into a particular environment? So we're seeing lots of uses of these technologies, but we have to build it, we have to prove it, we have to win trust, or we've got to demonstrate that it's scalable as a technology and it's also commercially scalable as well. So that's it from me. And I'm hoping We'll open up to the floor for questions. Feel free to challenge. No question is off the limits.
Thanks, Mike. Okay. So thank you, Mike, for a really interesting talk. And I'm sure there are lots of questions. Who would like to go first?
Oh, there's a microphone on its way.
Microphone's just coming.
Yeah, you put the propeller on each hull. I don't see any rudders. And also, how do you deal with when you go into port and you're doing a very low speeds? The lateral movement caused by wind, which might blow you off the key.
So the vessel's going to have bow thrusters on board, and then it's variable speed. So we can control each of the propellers independently and with a degree of sort of motion and movement. But what we ultimately want to move towards is a dynamic positioning system. So we're actually just able to pull it into the quayside with bow thrusters and the likes as well. There's a lot of regulation coming in currently from the MCA about actual operation in ports and harbour locations as well. So for this demonstration, we'll almost certainly have a safety boat alongside it at the same time.
Questions with Steve?
So the microphone is still high.
How does you won't actually know the range of the boat yet, I've not tried that, but we must have some calculations. How do you think the range compares with the amount of fuel?
So with the 6,000 litres on board, we're looking to achieve approximately 3,000 nautical miles. And hydrogen, liquid hydrogen, is a very energy dense fuel, which is where we get that. We're also moving at comparably low speeds. So this prototype vessel is going to do 4 to 8 knot, potentially up to 10 knot when we really have to. But is in terms of a total range about 3,000 nautical miles. Worth saying that actually from a remote operation perspective, so there are varying degrees of autonomy, but this vessel will operate over the horizon. So there have been examples where vessels, a couple of years ago, 2-3 years ago, there was a subsea earthquake in Tonga, sort of a volcanic eruption. The vessel that went out, the drone ship that went out to map that, was being operated from Tollesbury in Essex. So there was a safety boat out there. The people actually operating the vessel were 6,000 miles away in the UK, or probably more than 6,000 miles away. It's probably more like 10, 12,000 miles away. But they were a long, long way. So there's the ability. What you don't want to do, though, when it comes to site operations, is deploy the vessel. So this is where the modularity, the idea that you can essentially disassemble the vessel, put it in 40-foot containers, ship it to the other side of the world to deploy. Otherwise, it's going to take you a long time to get to a site like Tonga. You're going to burn a lot of fuel in the process on the way, huge amounts of biofouling and other things that will sort of take place during that period. The modularity also comes in from a cost perspective. So our vessel, it's 13.5 by 9 meters. If we were to simply ship that, pick it up, put it on the back of the ship, send it out to the Middle East, for example, probably cost us about $250,000 ship it once. You break it down into 2 40-foot containers, it's going to cost you about $14,000. So the huge cost saving that comes from kind of design engineering of making things that can be disassembled, put back together as well.
Question?
How have you got around the legal requirement to maintain a lookout at all times?
I should have had this very, very big slide. When I was talking about challenges, it should have just been the MCA sort of logo on the front of it. Regulation is the single biggest obstacle and hurdle, and it's particularly difficult being in the UK. And a couple of our biggest competitors have shut up shop and moved to Canada and the US and the like, where there are almost no regulations on autonomy. And the reason why is so much of the IMO regulations come from the MCA, it's the world leading flagging authority. So what the way the MCA worked is you essentially have to apply to class and get an exemption from class. And so current regulations are called the Workboat Code, Workboat Code 2. There's a new Workboat Code coming in. Been rumoured for a while. We're expecting it could even be announced in the next day or two as part of London International Shipping Week. So Workboat Code Annex 3 is going to come in, and it provides a lot of the information that was never, why wouldn't you have a lookout? Every boat has a lookout. Why wouldn't you have a captain on board the boat? Of course, a boat has a captain on board, but actually, as you move into autonomy, those sort of things become a reality. So what we've got to do from Work Mode Code 3 that's coming in now, and a piece of legislation called, or regulation called MGN 664, which is for anything that's new and novel. So the MCA takes anything, it doesn't matter whether it's fuels, whether it's autonomy, it all goes into a single document called MGN 664. Is we've got to show a comparable state with a crewed vessel at all times. So that means we've got to be able to demonstrate redundancy of all our systems, in some levels on safety systems, triple level redundancy, completely independent of the other system. So when it comes for lookout at all time, we've got to, within the remote operations center, we've got to be able to take a live camera feed and demonstrate that there's no lag or latency in that camera feed. We've got to record that data as part of a risk-based approach and keep it for 7 years to demonstrate on all the cameras. Now, that vessel is going to have a minimum of 12 cameras on board. So you'll have forward-facing cameras, you'll have peripheral cameras, you'll have subsea cameras as well, or sort of subsurface cameras on the nose cones of the vessel. So all of that data has to be checked and logged in real time. You've got to have the systems. You've got to use AI, machine learning to actually. You've got people sat there in the loop operating this at all time. The vessels, just for clarity, the vessels got waypoint planning and the likes, but there is somebody in a kind of computer gaming situation sat there managing it 24/7. What we're not doing is pushing a button, going home, having a good nap and coming back again. But then we've got to demonstrate those levels of redundancy. We've also got to demonstrate that the vessel will fail safe. So in the event that we lose complete communication and control, we've still got to be able to demonstrate that the vessel will operate in a safe manner. So that will be safety lights on, potentially that the vessel will navigate to a safe location and stay stationary, dynamic positioning, will remain stationary in location until it can be retrieved. We've got to have backup cameras, we've got to have backup propulsion systems and the likes. All of this is part of the cost. More onerous here in the UK, but what I like to think is if you can get it right here, we'll get it right anywhere. And that'll be a strategic advantage for UK companies that are looking to go abroad. Whereas a lot of our competitors are doing what's cheapest and easiest.
Any more questions?
Thank you. I hope everyone in the room can hear me. It's a bit hard sometimes. I just wanted to ask you about the infrastructure readiness. You mentioned it a few times, but we live quite close to the influence in Cromty Freeport, where they're developing plans for a hydrogen economy. I wondered if that would link into your thinking as well, or was it completely separate? But the other thing, you mentioned lithium-ion batteries, and I just wondered, I don't think I quite followed your train of thought about, are you going to be needing those and addressing the mining and disposal aspect of that?
Three great questions. I'll take the first one in terms of infrastructure. We're getting really conflicting messages from the UK government on the future of hydrogen. And I think anyone that's been around long enough will know that hydrogen has gone through multiple hype cycles. The challenge at the moment, as I said, hydrogen certainly not green hydrogen, liquid hydrogen not being produced in the UK, it's all been shipped in abroad. The facilities that are being developed here certainly appear to be focused on a European market rather than the UK market. Now, Air Products, who are the largest manufacturer of hydrogen in the world and distributor of hydrogen in the world, they're going all in on hydrogen, as you would have thought. They also do ammonia and various other things. So they're going to be converting their ammonia store in Immingham Port to basically convert ammonia into hydrogen through ammonia crackers and the likes. So that's a huge investment from Air Products. And I believe they broke ground on that facility only a couple of weeks ago. So they very much are in the steer. On the other side of things, British Gas Centrica have said, never hydrogen. Not going to be hydrogen, ain't happening, don't even think about it. So we've got these really competing. Hydrogen, as I said, Joe, lots of benefits, loads of challenges as well. And we're sort of navigating through that. So we're trying to stay fuel agnostic. This is a bigger problem for the whole industry because nobody wants to take the risk. That infrastructure is going to cost, the ports don't want to take a risk. If they put the wrong infrastructure in and it's not, what's the fuel of the future in the marine sector? I think it's going to be a bit of everything. some of the big carriers, so Maersk, have gone ammonia. UK ports and harbours are saying, we're not going ammonia, we're city centre locations in a lot of examples. I mean, at the North Harbour, it's at Aberdeen, I believe is the oldest harbour facility in the UK. You've got residential flats, 10 metres away off of the sort of the quayside. So when it comes to toxicity, the heat that's involved in ammonia cracking, the energy that's required to crack ammonia just doesn't feel like the type of solution for small vessels. But then something like e-methanol starts to become very exciting. The challenge with e-methanol is a lot of the fuel cell technology is about 5 to 10 years behind where the hydrogen technology is, so it's not quite there yet. So at the moment, we're in this sort of race where nobody is taking a gamble and we're kind of spreading everything, spreading the risk, which is why, if I sounded uncertain, we're going down the hydrogen route, but we're not wedded to that. And so a lot of the development with the hydrogen powertrain system and with the pontoons beneath the waterline, the idea is that essentially a hydrogen tank could be removed in its entirety and replaced with a methanol. We've got to look at volumes, what the impact is on range and power for payload and the likes. But that's all part of the thinking. So we want to be as fuel agnostic as possible. Ties into the second part. Essentially, that system, that hydrogen powertrain system, or in future maybe a methanol system, is a range extender for batteries. So what we're doing is the process for that powertrain is the cryogenic liquid hydrogen tank. We use heat exchangers, turn into sort of gas, put it through a PEM fuel cell, use the PEM fuel cell to charge the electric batteries. Those electric batteries are lithium ion. And that's where we're headed towards the zero solution, because the actual fuel of choice could be green hydrogen. But actually, when you look at the full life cycle emissions of the vessel as a build, when you start to look at an EV car, zero emission from a fuel and a charging perspective, in theory, if it was coming from renewable sources. But actually, that lithium-ion battery is probably about up to 60% of all the emissions from the production of a Tesla car is just in the lithium-ion battery. Quite disposing of them at the end, and they ain't nice things. So one of the things, and I don't want to sort of shoot myself in the foot too much here, we've got a cause and we realize this is going to be there's no such thing as a silver bullet. We're taking sort of little steps and sometimes step backwards. The lithium-ion batteries, we can't afford to have a fire on board. Full of hydrogen. And as I said, the biggest risk from the hydrogen propulsion system came from the lithium-ion battery. So our lithium-ion batteries, they weigh about 450 kilos. They're about 35,000 pounds per battery. We have 8 of them on board. Those lithium-ion batteries are actually submerged in dielectric fluid. So no oxygen for combustion, but also it acts as for cooling. So rather than having big chiller units, which you would have on a traditional vessel to cool a lot of your electrics, what you're actually doing is you're submerging this in a dielectric fluid. That stuff is not nice. That's the sort of stuff you don't want to be touching, which means there is a big environmental consideration when it comes to the disposal. And I think what's happening in a lot of industries is people are betting on the future catching up with us around decommissioning and disposal, and it's not there yet. So I think there is a brewing potential mini crisis, a reputational crisis. There is no doubt of where the end goal should be. But the steps on that I don't think are as clear cut as some people would like us to think. So I think there's going to be multiple stages to that progression. Hopefully that answered the question.
Question at the back and then one at the front. Back first and then the front. Yeah.
I have two questions. The first question is that in the case of the fuel leakage, like the hydrogen fuel leakage, it can maybe take more disruptors than the air-based fuel. And even you talk about the hydrogen can be a greener solution, but in the case that is leakage, it will maybe cause more disruptor compared with the air on our marine environment. So what will be the protocol that I may mention for the mitigation? And also, I think the hydrogen-based vessels are great, and it may have the potential to decarbonize the UK fishing sector. So what step have you taken to consider the role of hydrogen-based vessels in the future of the UK fishing sector? For example, 2.5% of people in the Orkney are regularly cleared in the fishing vessels? Thank you so much.
That's a fantastic question. On the particular one. I'll answer the first one around the dispersal of fuel into the water. So obviously, sort of hydrogen is a sort of abundant element. All of the research and science which we're relying on, is that dispersal into the water will cause a risk and hazard up to around about a meter from the point of dispersal. So when hydrogen, so if there was a catastrophic explosion, we can get an incredibly big sort of heat blast and an area that you don't want to be in. If it's a slow, the most likely scenario is going to be an impact. The tank itself is highly unlikely. You're talking about, I think, there is a stat in the research document. I'm going to say it's somewhere in the region of a 1 in a million chance that the tank itself ruptures of its own sort of point of failure, even in maintenance cycles and everything are maintained. The most likely point of actually mass dispersal of liquid at the volumes that are required, because a small leak really isn't going to cause any potential sort of damages. But if there was a massive rupture, it would come from a collision with another vessel. So in that instance, actually, the environmental impact becomes a lower consideration than the vessel that's probably just collided with you. It's unlikely the tank rupture would be from us hitting something else. It would be the other way around, something coming in sort of as a side impact. In that instance, the biggest actual risk is you still need, so the environmental risk to the marine environment is incredibly minimal unless something's nearby. The biggest actual risk would be that immediate release of any type of sort of bubbling, anything that came to the surface. If there was a point of ignition on the surface, there is the potential you would get an explosive force on the surface. Again, the radiuses for those are incredibly small. So you're going to have to be a very sizable, so it's a 2.5 ton steel reinforced tank. You're going to have to be a pretty sizable sort of vessel to have that sort of impact. So I'd be happy to share. There is going to be a report out, independent report, looking into our vessel and some of the considerations. It was written by the University of Strathclyde and by an independent consultancy firm called Gexco. So I'm happy to probably publish over the course of the next couple of weeks a bit more information on the risk assessment from the environmental side. But the answer is, it's not going to be as bad as people think from the environmental side. Mostly it'll be dispersal. I think you'd be very unfortunate if a marine mammal just happened to be alongside at the point of collision or leak. The second question around fishing vessels is a fascinating one. And it talks to one of the challenges of the marine sector, because there is an incredibly successful aviation company called Zero Avia, who've raised tons of money recently to develop and retrofit hydrogen powertrain and propulsion systems onto aircraft. One of the real opportunities you have in the aviation sector is you have the likes of Boeing and Cessna and all of these sort of great sort of plane manufacturers build lots and lots of planes to the same shape and size and sort of and designs. When it comes to the marine sector, you encounter naval architects who take real pride on the individuality of so many vessels. And one of the real challenges we've faced is actually retrofitting a fishing fleet. It's very, very difficult because every single vessel has got different size compartments and wiring and all of those elements. You would potentially have to look at a complete refit of the vessel top to bottom. And so therein comes the economic cost, because you could be talking at about 500,000, 700,000 to replace a traditional diesel propulsion system on one of these. You could be talking north of about 1.2 million to do the same with a hydrogen system. You then need the hydrogen infrastructure on shore to be able to refuel it. And so suddenly this becomes a less attractive option. We are looking at a study coming up to look at taking our hydrogen powertrain system and putting it onto a true transfer vessel to look at that ability to retrofit. But it's very, very difficult until one of the large providers go, right, we're going to be rolling off 40 crew transfer vessels or 40 sort of fishing vessels. Actually going to this type of propulsion system is going to be very, very difficult just because of the cost. Nobody's going to invest in this at this stage. So unfortunately, we'd love it to be different. I'd love to be able to sell a powertrain system design to a whole load of manufacturers and go, right, here's a license, proven it's tested. Re-engineering the retrofitting, it just makes it largely unscalable at the moment. Hopefully that will change.
There was another question. at the front. I'm also aware that we might have people online. Mike, is there anybody asking questions online? No, it's fine.
I have this sort of surreal dystopian view of the whole this vessel whizzing around on the sea in the future. And I just wonder, you know, if I go out on my yacht and capsize,
Yeah.
and I'm upturned sitting on the turnpike, and one of these vessels goes past, is there any hope of rescue? Is there any kind of responsibility still for the, you know, aid at sea? Not much for me, because I probably aren't going to go out and poach and get. But
Yeah.
people in the English Channel,
Massively so.
you know, and other people that need assistance.
Fantastic question. So SOLAS, safety of life at sea, still applies. Where you can render assistance, where you are the most suitable vessel in immediate proximity. So I think there's a double-edged Joe. Is it going to be that vessel that pulls alongside and a robotic, you know, sort of ladder goes down, bringing somebody aboard? No. Is it a potential for thousands of these vessels to be deployed at sea doing monitoring and protection? Now, you could be doing pipeline inspections at the same time as providing general awareness of an area around, you know, it could be small craft, it could be, you know, vessels in distress and the like. So there are more opportunities for eyeballs and that geographical coverage through this type of solution. There is actually a automated drone rescue vessel called Zelen. So this is not my company, this is another company, but they've actually developed an entire, it looks a bit like one of those running machines that I clearly don't go on very often, but those home running machines or the gym running machines. And it basically will detect, using AI, it will detect man in the water or person in the water, wind farms or cruise ships and the likes, deployed into the water, scoops up underneath you with a travel agent. This is a genuine, this is an actual, this product exists, and it'll scoop you up, and then you'll sort of be laid on it while somebody comes and rescues you off of this product. It's been invested in by some of the really big sort of shipping liners and offshore sort of crewing organisations. I think Lloyd's Register invested in it as well. But there are those types of solutions. Different horses for different courses again, but I can see a world in which actually you want that distributed coverage for a whole range of reasons. But I think it provides you with that eyeballs, that certainty. And so a lot of what this is, again, it's just using AI, it's using smarter technology to say there is a problem and then getting the right solution to come. Better to be found and be waiting a couple of hours while the right solution rather than bobbing up and down sort of endless periods of time. But I do get those concerns as well, you know. So these sort of vessels, apart from all the cameras on board, they have microphones, you know, loud hailers. In fact, we've got to one of the questions around the safety case sort of comparison. What we've got to demonstrate is not only have we got a loud hailer on board, but we actually need a microphone on board to demonstrate that we are actually broadcasting. Because you could be talking down the microphone and the loud hailer is actually broken and you're talking to yourself because nobody can actually hear it. So we've got to have a microphone to be able to prove that the loud hailer is working and that it's transmitting. So there's lots of considerations sort of like that as well.
Oh gosh, lots of hands. Go for Evelyn at the front and then drop back.
Thanks. It's really interesting you were saying about a small leak. Okay, it's maybe not very likely that it's going to happen, but a small leak in a hydrogen vessel is not like an oil leak. It's going to rapidly run out, isn't it? So it's interesting in terms of your backup and fail safes. You know, you mentioned one of the competitors had a diesel engine on board and these sort of backup systems. So just maybe comment on that. And also, I know you did mention green hydrogen, but with your sort of saying you're trying to be fuel agnostic, I take it then for this trial that if there wasn't green hydrogen available for you, you'd be quite happy to use hydrogen that's created in some other way. So again, just your view on that.
Two excellent questions again. So in the event that there was a failure of the hydrogen propulsion system, the battery system alone would give us about 10 to 12 hours of operational time to get either into an allocated safe zone, which is predefined, and it would remain in that location, or potentially even back into port, depending on various conditions. So that is part of the redundancy system. The second question around green hydrogen. it's a really tough compromise because you go for, our vision has been based upon sustainability, but there's also a practical reality of you've got to demonstrate the technology works. Ultimately, the main consideration is the purity of the hydrogen going through the PAM fuel cell. But you're absolutely right. There are grey hydrogen, one that nobody wants. There's blue hydrogen, which is not quite as bad as the grey hydrogen. I've now heard that pink hydrogen, which is from nuclear, might be the most likely source of hydrogen in the UK in future if we do invest and go down that route. Ultimately, the challenge with the green hydrogen is, given the whole supply chain is coming in from Amsterdam at the moment, we would have to bunker the vessel in the Tees Valley Hydrogen Hub, which is the port of entry into the UK for the hydrogen. We'd have to bunker the vessel there and then take it out from there to sea, because the second anything goes on, then transported on land, then it's not green anymore. So I think there is going to be there's a long period of compromise, and I think it's just making sure that we don't compromise too much in terms of where the end site and vision is, but is that proof and use case. So and the same applies for other types of fuels as well. Is green and sustainable has to be the goal. I don't think the journey there is quite as clear cut as some commentators potentially make it out to be. I'd love it to be. Boy, am I passionate about it getting there, but I don't think it's quite as factual as it's sometimes made out. Thank you for the question.
There's another question back there.
Just wondering if the fusion head or fairly regular, gale force winds around the island have any impact?
Massively so. So we're working through our ConOps concept of operations at the moment. So the wider team, I'm sort of here tonight, but we're a small company, there's only 12 of us, but about 5 or 6 of us are just exited from the Royal Navy. So we're working with a whole range of experts around this, but you're absolutely right. Tidal flow, sea state conditions, sea height, actually the frequency of the sea heights, as you said, the gale force wind, all of these add up to the operational windows. So on the video, when I was talking about the tow tank testing, where the vessel was being tested in 2-meter sea states, so Chevron, when it comes to asset integrity inspections, anything subsea, 2 meters they down tools. That's the safety limit. 2 meters too risky for their equipment, but more importantly, the people on board. That gives them around about 100 days of operational time a year in the North Sea. That's it. All the rest of that, the other 260 days, that's money that's not being made for them. You move that up to 3 meters, and you go from 100 days to 165, 170 days. That's a lot of money at $50,000 a day. You move that up to 4 meters sea states, which is where we want to be pushing, you're suddenly at 220, 240 days of operational time. So a lot of what we're going to be doing is working on the weather windows. I flippantly made a comment earlier around, I'd love to be seeing you all in August, September next year. I don't fancy taking a prototype out, in all honesty, as much as I'm backing my equipment and investment of the UK taxpayer. I don't want to be testing this in sort of North Sea conditions in December, January, February, partly also because there is a lot of time that's spent out on quaysides, and it's probably not going to be particularly pleasant. So you're absolutely right. Working to those weather windows is absolutely critical. When it comes to things like logistics runs, I think if you're doing inter-island, and the learnings I've had, I mean, I'm somewhat embarrassed that this is my first trip. It's such a beautiful part of the country and the world. Actually, I've been amazed at just how sheltered some of the bay areas are, and some of the potential movements of vessels could be longer when you've actually got sheltered condition. But you're absolutely right, in the North Sea, there are certain times of year where doesn't matter how good the vessel is, you don't want to be able to see.
Are you happy to take another couple of questions?
Yeah, absolutely, yeah.
So I think Dave's had his hand up a few times. So
Sorry, Dave, I'll fill this.
and then we'll go there, and then we'll see how much time we've got.
Okay, perfect.
When do you order hydrogen from Amsterdam, delivered by a lorry and ship to Aberdeen or Southampton? And that's fine. Then you put the hydrogen in your boat and it's suddenly dangerous.
So it comes down to the conversation around the The conversation around the green hydrogen was related to anything that goes on a diesel truck is no longer green because of the range of. But you're right. So the way the bunkering will work is failing us taking the vessel to the Tees Valley, the port of entry. What we will be doing is we will be essentially bunkering it into a 3.5-ton truck and then moving the 3.5-ton truck to us where we're located.
But I'm still saying, it comes to Teesside from Amsterdam.
Yeah. It does, yeah, correct.
What's the difference? It's just a.
Well, completely. Well, I mean, it's on the back of a boat. So again, my complete counterintuitiveness. That is a marine diesel powered vessel. That's coming over in big tankers and things. It's yeah. So you're right. Essentially, it's probably not green by the time it's left Amsterdam, but by the time it gets here.
But it's safe.
It is safe. Yeah, absolutely. I mean, well,
It's safe to go for it.
well, no, it is. I mean, the hydrogen when it's good, we're incredibly confident around the safety credentials of it on the vessel. There are going to be instances. The risk-based approach we have to go through with the MCA. I'm not joking. The example they gave was, what happens if my vessel has broken down? Somebody thinks it's a crewed vessel. People are in distress. There just happens to be an undiagnosed rupture and venting on your vessel. Crewed vessel, a sailing boat with family on board, pulls it up alongside, ties themselves up, gets up, and the guy's having a cigarette. And I was like, I'm not sure there is any risk assessment that I can go through that can disprove that sort of example. But no, and again, it was that was genuinely hand on heart. That was the example the MCA gave us. It was what if, and I was like, there's an almost an end. But in terms of the fundamentals of the design, both we are exceedingly confident in terms of the safety credentials of the liquid hydrogen once it's on board the vessel. Doubly so once it's in the water with the ability to disperse into the water. As I said, there are still risks. If you have that catastrophic failure, if you have the bubbling to the surface and an explosion on the surface, there are potential sort of ramifications on that. But that's all part of what the safety-based approach is. But you're right. There's a lot of nuance in some of these discussions, and I think there's a lot of learnings. This is also why innovation is funded and why I'm passionate about. The UK is the world leader when it comes to innovation funding. I think Innovate UK sort of invests about £1 billion a year. This is the Clean Maritime Demonstration Competition. It's a lot of taxpayers' money, and vast majority, 90% of startups fail. But you've got to take those risks for those ones that succeed. I'm hoping that the UK is going to get better and ensuring that we get the Elon Musks of this world, because we need the success stories at the end of it. But you have still got to take risks, and there's a lot of risk in our project. I don't think it's necessarily safety risk. I think that's where we are so tight and strict on it. But I think there are lots and lots of risks for us to consider, and we'll learn as we go along.
I hope you don't mind me retreading over a subject you've already discussed, but the lithium-ion battery thing
Sure.
is something I've sort of read about and have seen about. My uncle is an electrical engineer, and he always said that lithium-ion batteries were the one type of battery the manufacturer will not guarantee will not catch fire.
Right.
So to me, this may be my coming from a point of ignorance, I don't know, but it seems like if any kind of concern on this ship is not the hydrogen, but actually the battery itself.
Correct.
Do you think my question comes to are you going to be battery agnostic as well as fuel agnostic? Do you see that's going to be a sticking point where it comes to the supply and demand from a government that seems pretty hell-bent on having a country of electric cars, that you have to dig this stuff up still? There's only a finite amount of this stuff. Do you see that's going to be a sticking point? Are you looking at other options for it?
I literally had this debate with somebody. Not debate. I'm fully. I had this discussion with somebody this morning. I think we will have electric vehicles. That will be the vehicle propulsion of choice. I think the battery technology. It's not too dissimilar to phones. You think the number one frustration with all our mobile phones and our laptops is that after 2 or 3 years, you got to go out and buy a brand new Mac because the battery's rubbish. This is also the challenge with lithium-ion batteries, down to 74% after 3 years. 5 years, it's being buried in the ground somewhere. So I think that battery technology it needs to get smaller, it needs to get lighter. It's 450 kilos and 35 grand. But at the moment, the lithium ion batteries are the most sort of power sort of dense. They give us what we need. But I think, again, pretty sad. British fault. UK-backed startup had £1 billion of potential investment. I think it was up in Northumberland. Was allowed to fail and be acquired by an Australian venture capital firm for peanuts, 20 million. I think they bought up the site and facilities and the technology. Now, I'm not saying, okay, bad startups who are throwing money around on private jets and parties for executives, they need to fail. They need to go away. But actually, we need more. We need to be making more batteries. If we're gonna sort of go in this direction, which I think is the most likely direction, we've got to be investing in backing in that type of technology. I'd love a cool British or European or battery manufacturer to come around and say, look, we found something that's more environmentally friendly. I don't think perfect's going to be around for another 20, 30 years. But I think those gradual sort of iterative improvements, those are the companies I like to work with. And actually, there's an open, apart from that, I'd love to come back and talk to you in a couple of months' time about sort of progress and things. But also, if any of you are working in the sector, if you've got potential partners, opportunities, it's also very difficult being a startup because every so often you hear about this cool company in New Zealand that's doing liquid hydrogen liquefaction plants, mobile plants. So I was on the call with them this morning. So actually, because this is new and novel technology, it's very disparate as well. So if somebody does know of a brilliant sort of battery manufacturer that's maybe slightly friendlier than the Kriesel, which is an Austrian battery that we're currently using, please do let me know. We're doing a strong market sweep, but we also love to find new people to partner with.
I'm going to take one last question, I think, from Sandy at the front here. Just here, down here. I think this will need to be the last one.
Okay.
Give you a chance to get a cup of tea.
I'll hang around for last questions answer. But
sorry. Excuse me. Somebody once described hydrogen to me as probably going to be something we need, but it's going to be a champagne fuel. And what they were saying is it's not going to be cheap to make, and certainly compared to existing fuels that we use in the maritime sector, and particularly heavy fuel oil, it's the cheap thing. And that's driven, it's meant the industry is developed in a certain way. So I'll get to my question. Given that you are going to probably end up using a fuel that is going to be a lot more expensive, what's about other changes is that going to catalyze in the sector? Do you think we're going to see hybrid solutions like wind-assisted hydrogen vessels? Are we going to start sacrificing speed? We're slow at sea. We're going to maybe sacrifice just in time. All these things that have been viewed because we've got cheap fuel.
Outstanding question. The current price of liquid hydrogen is about $22 per kg, or per liter, which is what 25x on marine diesel. So it's very absolute champagne. There's some interesting. A lot of this is also geopolitical as well. So the economists' forecast for hydrogen in the US is that it will reach parity by 2030 with diesel, partly driven by the Biden administration's $1 billion, I can't remember what it was called, the big act that he passed end of last year. What they're actually looking at is hydrogen subsidies. The other thing that started to open up is some of the emissions. So if you're moving towards zero emissions, you start to open up new financial models whereby you are essentially compensated by people that are emitting are buying your zero emissions. So a quick estimate on our vessel using liquid hydrogen. So if we were replacing one crew transfer or a small vessel, sort of crew transfer sort of size vessel that was doing North Sea oil and gas runs, parts and components, we'd be saving in the region of about 5,000 kilos of carbon emissions a year, which is the same as the carbon capture facility in Iceland. Costs about 50 million built for that direct air capture facility. And I don't know if you've seen it. I think it's called Climate Works. In Iceland, it's sucking all the carbon out the air. Great solution. We need stuff like that, but it's at huge cost. And so I think there's going to become this interesting new financial model. The problem with financial models is they're great while they last until somebody starts to, and until essentially the market sort of dries up. But it's a really, really interesting point, and I think we will see. I was having this discussion 2 years ago. People were like, "Yeah, it's going to be $15 by the end of the year," and it's actually gone up, if anything else. So it's it's an interesting challenge. Sorry, Sandy, was there a second part to your question?
Is there going to be any other sort of changes to how the sector works? So we're going to be operating slower vessels or hybrid?
Sorry.
Hydrogen plus wind.
And I love that because there's it's amazing. It's a bit like sort of 1980s fashion. That's for 20 years later it comes back around again. If you look at the wind sector, so there's a fantastic project currently being deployed to use sort of wind. And sails are getting smarter. It's like tubes and a whole load of stuff that's way beyond my pay grade. But I think you're absolutely right. The Royal Navy did a deployment with a wind-powered vessel in the Caribbean, and it outperformed every expectation they had. So I think you're right. You can end up with these hybrid systems, and it comes down partly to actually to a redundancy system as well. Can you optimize? So when the wind is in the right direction and your sails are up, fantastic. When it's not, you convert onto another. So actually on the deck of the vessel, one of the iterative designs we've got is just a whole load of solar panels, because if it's sunny, why not? How long is that going to add per day or over the course of multiple days? It might give us a couple of extra hours a week of power, but that's better than nothing. And that can run some of the systems. So I think your app's 100% right. I think again it'll be different sizes of the vessel, different sort of requirements, capabilities. Some things will be required, will require speed for interception or, for just-in-time logistics. Other things, life may just take a little step slow. I don't think is necessarily a bad thing either. Great question.
And with that, I'd like to thank Mike again and thank you for the